Assalamualaikum and good day everyone. So today we are going to present about the mechanical structure and properties of food for the subject EPF 3001 Static and Strength of Materials. So today we are going to present about the mechanical structure and properties of pasta. Have you guys heard about pasta before? And what is pasta? Let me explain to you what is pasta. Pasta is a type of food typically made from unleavened dough of wheat flour mixed with water or eggs and formed into sheets or other shapes, then cooked by boiling or baking. Rice flour or legumes such as beans or lentils are sometimes used in place of wheat flour to yield a different taste and texture, or as gluten-free alternative. As you can see, there are several types of pasta with different size and shape. Mechanical properties of pasta.
First method, compression extrusion test. Usually for the test we will use Ottawa cell. The test to determine the firmness, springiness and the work of pasta. The test applies a compression force with consequent extrusion. Both the base of the probe, which is 60 x 60 mm with 67 holes each 6 mm in diameter, and the probe, which is made up of numerous dies, are made of aluminum. Next method, which is shear compression test. Usually this test will use Kramer shear cell and usually used at an industrial level for sheets with large diameters or widths. This test destroys the sample and involves lengthy measuring times since each time the probe is used. It has to be disassembled, meticulously cleaned as piece of pasta kitchen between the blades and reassembled.
Next, the measurement method involved is double compression test TPA. The function of this test is to determine the firmness, springiness, stickiness and also the cohesiveness of the pasta. The equipment needed is called as Pasta Firmness or Stickiness Rig HDP PFS. Here are the procedure on how to carry out the double compression test TPA. An example of the use of this test also highlights the difference of noodle sheet stickiness depending upon the hardness of the cooking water. Some researchers have demonstrated that as cooking water becomes harder, which is the calcium carbonate increases, then the cooked noodles will become stickier. Others also have reported that processing noodles under high temperature drying conditions may partly overcome cooked noodle stickiness. Although water hardness doesn't affect cooked noodle firmness, it has a marked effect on surface stickiness. Thus, prepared water of constant hardness and pH should be used for standard cooking tests and also should be considered when distribution of pasta or noodles to soft water area is inevitable.
The next method, which is AACC pasta and noodle cooking quality firmness 6650.01. This test is to measure pasta's firmness during cooking, particularly for long cut pasta shapes such as spaghetti and noodles. The equipment that can be used in this test is CS1 standard shear cell. Measurement method is calorimetry test, or we can call it as image analysis. This test is to determine the color of the pasta. We can use reflectance spectrophotometer for the equipment.
For the last measurement method, the experiment can be done using equipment called Texture Analyzer TexVol TVT 150XP, which is assist with a computer. By using this equipment, two types of test method can be done, which is firstly single cycle and secondly hold until time. From this method, we can measure elasticity, resilience, hardness, and adhesiveness. So, what is the difference between the two methods? Basically, single cycle and hold until time differs in procedure and observation that is taken. As for single cycle, the prop goes down in the aluminium cup and then right up again. While for the hold until time method, the prop is compressed in the cup and it is held down for a period of time to relax, and then the probe will goes up again. When measuring hardness by using single cycle, hardness will be measured using the same pasta but different cooking time. While for the hold until time method, different type of pasta will be used. In the procedure, pasta is compressed using the TexVol instrument, hence the right level of instrumental setting will be obtained, and the result that we will get is the peak force in unit of grams. In the discussion, we can see that by using single cycle method, hardness will increase at time from 5 minutes to 8 minutes. Then it will stay quite constant at 8 to 10 minutes. And after that, the hardness will continue to increase, but at maximum cooking time 30 minutes, then it will decrease. The lowest standard deviation at the cooking time is 8 minutes. While for the hold until time method, the result is pretty similar with the single cycle using different type of pasta, but on different level of hardness due to the different ways of calculating and different ingredient amounts. For measuring elasticity, the hold until time method will be used. In the procedure, the pasta is compressed to a certain distance. Then, the pasta is held at that compression state and changes in force in the pasta are measured. The result that we will get is peak force when the probe goes down and the force that tries to push up the probe while it is still standing. In the discussion, we can see that it can be seen that the elasticity is decreasing with the resting time. This is probably true because the pasta is getting colder, therefore it becomes less elastic. While for measuring adhesiveness, the single cycle method will be used. In the procedure, the TexVol instrument probe is pulled away from the pasta. Difficult parameter for measuring pasta, sometimes pasta straws are stuck to the probe, and if that happens, the number of straws attached to the probe will be measured. In the experiment, the result that we will get is force when pulling the probe away from the pasta. We can see from the experiment that the adhesiveness measurements are quite high when the pasta is cooked for just 5 to 6 minutes. Then it will become stable between 7 to 9 minutes before the value increase with its maximum value at 13 minutes. More than that, the values will decrease. Lastly, for measuring resilience, the single cycle method will be applied. The resilience is the value of how well the pasta can regain its original form or structure. In the procedure, the pasta is compressed to a certain distance, then TexVol instrument probe is pulled away from the pasta. Area during the withdrawal of the compression is divided by the area of the compression is calculated. and the result that we will get is the ratio between the two areas. In the experiment, we can see that the pasta that is cooked for 5 to 7 minutes is still quite hard, so the resilience of this pasta straw is less than the pasta cooked between 8 to 12 minutes, while the pasta that is cooked for 13 to 14 minutes has a lower resilience value than the pasta cooked for 8 to 12 minutes.